What is a translator? A translator is a software tool or a software program which can translate a source code to a target language. That is, we will pass a source language as in one language, and the translator translates that source language and produces the target language that is of another language form. So this translator is an intermediator between the source language and the target language. So there are three types of translators. One is compiler, and then one is interpreter, and the third one is assembler. So first we'll see about what is a compiler. So compiler is a program that takes a source language as an input and translate that source language to an equivalent target program that is of another languages. So the source language can be of high-level language that converts the high-level language into a machine readable codes. While the compiler reads the source language, if there is any error, the error message will be displayed and the target code will be generated as an object code. So the compiler executes the whole program during the compilation process, and the space required for the compiler is high since it takes complex program for compilations. So next type of translator is interpreter. So interpreter is similar to the compiler. So interpreter translates the high level instruction into an intermediate form, which it then executes the next sequence of instructions. So it also converts high level language to a machine code. So the main difference between compiler and interpreter is that it executes line by line in the interpreter, whereas in the compiler it executes the whole program. But the interpreter takes less memory space since it executes only the small program for the compilations. The third process of translator is assembler. So assembler is one of the lowest level programming language. This assembler acts as a translator and it translates the sequence of assembly instruction into the machine codes. So the assembler takes the source as an assembly language program, that is a set of mnemonics, and it converts to the machine language that is of object code. So these are the three types of translators in the compiler designs. So next, the difference between compiler and interpreter is that, so first it converts the high level language to machine language for compiler as well as the interpreter, and the second thing is that in the compiler the compilation process performed is for the whole program, whereas the interpreter it takes the line by line execution for the process. And the third difference is the compilation time is low for the compiler, and whereas the compilation time is high for the interpreter, where the errors cannot be rectified. So the next difference is that the compilation takes the complex program in the compiler, and whereas the interpreter takes small program for the compilation process. While it takes the complex program in compiler, it requires more memory space, and in the interpreter small programs are used for compilation, so it takes less memory space. So the 5 differences between compiler and interpreter. So far we have seen the 3 types of translators. So translator acts as a software tool or a software program that translates a source language to another target language. So next we will see the classifications of compiler. So the compiler is classified into some 5 types. So first one single pass, and second one multi-pass, and third one is load and go, and debugging and optimizing. So single pass, there will be only one pass done during the compilation process, and multiple pass, multiple passes are performed during the process of compilation. So next classification is load and go. So the registers will be loaded and then next process will be processed through it. So fourth is debugging, so errors will be rectified and then the compilation code will be optimized at the final stage of classifications. So next we are going to see the qualities of a good compiler. So the best quality is that the compilation performs quickly in the compiler. So while compiles quickly, it will runs the code faster, and the generated code by the compiler is an machine codes, and there will not be any errors, that is bug free environment in the compiler. So compiler is an portable devices, sorry, not devices, it's a portable one, and the correctness is the next quality of a good compiler. There will be a separate compilation for each modules. The code has been understandable and the automations are corrected. So these some few qualities of a good compiler. So next, what is the main requirement to build a compilers? To build a compiler, we need some knowledge for building a particular compiler. So first language is that a programming language is needed, and the second one, theory of automata in that context-free languages is the main knowledge for building a compiler, and then data structure and algorithms are the next knowledge where we are going to apply the compiler. And the fourth one is computer architecture knowledge, and the last one software engineering. So all these 5 core areas of knowledge is used for building a good compiler design. So we have learned the qualities of a good compiler and the knowledge of knowledge to build a good compiler. So what is the purpose of learning this compiler? The purpose to learn this compiler is to increase the ability of a new language. That is, we have to learn a new language to increase our ability. And the next is to learn the programming techniques. Small techniques can be learned through the programming skills, and we need to build a large applications. For that we need to study a compiler design, and separate software tool has to be developed. So to develop that tool we need to learn what is a compiler. So next thing is that a compiler provides an essential interface between the application and an architecture. So these are the some things why we are going to learn the compiler. The most thing is that to build a large application and to have a programming technique skill and to develop a software tool, we are going to learn the compilers. So in compiler designs there is a specific model to design, so that is analysis and synthesis model. So in compiler there are totally 7 phases. So these 7 phases is classified into 2 models, that is we say it as analysis part and synthesis part. So we have named this as an analysis synthesis model. So there are 7 phases in a compiler. So first one lexical, second one syntax, semantic, intermediate code, code generation, code optimization, and symbol table and error handler. So the analysis phase takes the source language to intermediate code as an analysis part. So during this stage from source language to the intermediate code, the source program will be divided into some pieces of codes, and it create an intermediate representation for an source code. That is, the source program will be split into an identifiers, that is we say it as in consecutive pieces, and it will be created an intermediate representation for that identifiers. So it will be splitted based upon the source program. The source program will be different forms. For example, we can take it as a equal to b plus c minus 50 as an source program. So in this example, a equal to b plus c minus 50, the identifiers and the operators will be divided. That we say it as we are going to split each and every characters as an pieces. So this is, we say it as an analysis part. So analysis part is from source language to the intermediate code, and after intermediate code your synthesis part takes role. So from intermediate code to object code, your synthesis part acts. So from intermediate code, the target program code has been generated. So from the intermediate representations, this intermediate code will process the code. So some temporary variables will be used for the code, and after using the temporary code, the code optimization techniques optimizes the temporary code, and the last phase, code generation, optimizes the getting the input from the code optimization. The code generation develops the code to an assembly code, and then the object code will be generated at the last phase. So this is the two parts. So your compiler is classified into two, analysis part and synthesis part. So analysis takes from source language to intermediate code, and your synthesis part takes from intermediate code to the object code. So to build a compiler, we need a software tool to manipulate the source languages. So there are some of the tools that manipulates the source language are structure editors. So what is a structure editors? So structure editor takes input a sequence of command to build a source program, and the structure editor performs creation of text, modification of text, and it will analyze the source program to make some concept. And the additional tasks that has to be performed is that the input form should be checked correctly. If the input is wrong, then we cannot perform the operations of in the source languages. So structure editor is that it will be a sequence of commands to build the source program. We can create the text, and we can modify the text in the structure editors. So next software tool is that pretty printers. So pretty printers mainly analyzes the source program, and it prints the structure of the program so that it will be clearly visible for the users. Some of the examples of the pretty printer are: commands may appear in the special fonts. This second example is statement may appear with an amount of intentions proportional to the depth of their nesting in a hierarchical organization of the statements. So whatever thing we need to print with the help for the analysis of the source program, the structure of the program will be printed. So next is static checkers. Next tool in the analysis the source program is static checker. So the static checker reads the program and finds any potential error is there while during the runtime of the program. So static checker mainly analyzes the source program and finds a potential error without running the program. So examples is that it detects the part of a program that can never be executed before, and finds those variables that may not be used before being defined, and it catches some of the logical errors before the runtime of a program. So static checker is mainly for finding the potential errors before running a program. So last one is that interpreter. So interpreter we have seen before itself. So interpreter takes the high level language as a source program and converts the target program that is your as a machine level language as a low level language code, and the interpreter executes the instruction by line, and it takes the small program for the compilations, and example is that it creates a syntax for assignment statement and performs the operations at the nodes. And these are the 4 types of software tools. One is structured editors, pretty printers, static checkers, and the 4th one is interpreters. So some of the examples that performs the analysis part for a conventional compiler is that text formatters, silicon compilers, and query interpreters. So text formatters, it takes the input a stream of characters, out of which most are to be text of the typeset, and some individual but some includes commands to indicate the paragraph, figures, or some mathematical structures like subscript and the superscript process. So text formatter takes the sequence of characters from a particular text. So next is silicon compiler. So silicon compiler takes the source language as an input, but the variables in the input represents not the location in the memory but the logical signals, that is zeros and ones in a switching circuit. The output in the circuit design will be of appropriate languages. So it represents the input not in the location of a memory but the logical signals that will be of zeros and ones. And the last example of analysis part of a conventional compiler is query interpreter. Query interpreter translates a condition containing relational and Boolean operators into commands to search a database for finding a record to satisfy a specific conditions. So to translate a specific condition containing relational Boolean operators, query interpreter is used. So this is the structure of and phases of compiler. So phases of compiler, it takes the source language program and interacts with all the phases of the compiler designs. So symbol table and error handler will access all the 6 phases. Symbol table is a data structure that stores the data present, and the lexical analyzer gets the source program as a language, and the lexical analyzer will split the source program into several parts. After splitting the consecutive pieces of the source language, the output is passed to the syntax analyzer. The syntax analyzer reads your source language and construct the inputs in the form of tree, that is either in the form of parse tree or a syntax tree. The syntax analysis, or otherwise we'll say it as an hierarchical analysis, and the output of your syntax analyzer will pass as an input to the semantic analysis. So semantic analysis checks the semantic errors present in the source language, and after checking the semantic errors, the semantic analyzer sends the output to the intermediate code generations. The intermediate code generation reads the information from the semantic analysis and generates the code with the help of intermediate representations. Intermediate representation has 2 properties that satisfy. It should produce easy way and to translate the code in an target code in an easy way. So to represent the intermediate representation, there are 3 methods. First method is 3 address code, second one is syntax tree notation, and third one is postfix notation. So normally we will use 3 address code for representing your intermediate code. So it consists, the intermediate code will be a sequence of instructions And after generating the intermediate representation, the code optimizer takes the input as an intermediate representation of code, and the code optimization will optimize the code for the further process. So the code optimizes improves the source code from the intermediate code generation and sends the code to the final phase of the compiler, that is code generation process. The code generation is the final phase of the compiler. It generates the target code that consists of relocatable machine code or assembly code. The symbol table will contains the data. So all the phases will access the data if necessary from the symbol table, and it will use it. And each and every phase, the error handler will check the errors. If there is any errors, the error handler will print the displays the error messages. So each phases, the errors will be detected. So in lexical errors, the detected errors is where the characters remaining in the input do not form any token of the languages. So if does not form a token, then lexical error will occur. In the syntax analyzer, the error handler errors may be token that violates the rules. If the rule condition is not satisfied, the syntax analyzer error can occur. And the semantic error is that it detects the construct that have right syntactic structure but no meaning to perform the operations. In intermediate code, the errors may be to detect an operator whose operand have incompatible types. And in code optimization, the errors will be on doing a control flow analysis, may detect a certain statement that cannot be reached in the form. Okay. So while you are optimizing the code, we cannot reach the flow of code during the optimization. So that time your code optimizer error handler will handle the errors. At the final phase, the errors may find a compiler created a constant that is too large to fit a word into the target machines. During that time, error handler will rectify that and it will solve it, and the final output of the code generation will be of your object code, that is the target program is processed as an output. So these are the phases of a compiler. In the next session, we will see a detailed example how the phases works with an source program. Okay. So far we have seen what is compiler, what is assembler, what is interpreter, what is the difference between compiler and interpreter, and what are the tools that manipulates the source languages, that is structure editor, pretty printer, static checker, and query interpreter. And the final thing, we have seen an overview of what is the phases of compiler design. So thank you.